Okay, hello all. It's David Praise once again. So today's tutorial will be going through data visualization, like a data visualization walkthrough with Python. So we're gonna if you're all familiar with like all these visuals and plots that I guess you've been making in different classes, we're gonna do that over here. But instead of but now we're gonna do it like with Python programming language. So we'll be working with like different data sets, like with the Iris and also with the Titanic if we have time to go through that. And so basically I could start by importing our necessary libraries. So I import numpy as np, import pandas, spd, import matplotlib, .pyplot, splt, okay. So now let's start by loading our Iris dataset. So, of course, in Anaconda or in the Colab environment, which I'm using right now, a scikit-learn library has already like been installed, and within it there are like data sets that are great for learning. So I recommend you to also check out those data sets in scikit-learn and also to practice using them. So now I'm gonna start out like importing our data from scikit-learn. So from sklearn dot dataset import, it's called load iris, and over here you see like load Boston, load breast cancer, load diabetes, but for this tutorial we're going to use load iris. All right, so once you've got that imported, now we're going to do some a very important step in like in data science, which is like called exploratory data analysis. So in this problem, we're gonna try to like understand like the severity of the problem. So we're gonna see like the dependency between feature vectors, whether all like the data is correct or like some values are missing and so on. And and we're gonna do like a lot of great things. So we could start by loading our data set. sklearn equals load iris. So basically iris dot data. So basically these contain our feature vectors and you could see it. So here we have like over 150 samples, and as well as we do the same thing for erase.targets. And also over here we have like these target values. So basically, if you're not familiar with what iris is like a type of flower. Of course, you could check it on the internet and you can see it. And we have like certain informations about this flower. So if we check, like for example, if we read the documentation for iris.scikit-learn, we could see the describe over here. Okay, that's not enough. Good move. This might give you something. Yeah, perfect. So you could see like it's a plant, So, and you could see what it contains. There, like the number of instances, so the number of samples, the number of rows, you could call it that way. So there are 150 samples, and within like this feature vector, they are like split into three different classes, and these are like 50 different samples that are split into three different classes. So the total length in our case over here is like 150. We could also see that it has like different number of attributes. So these are also known as columns. So these are like for numeric and predictive attributes and the classes. And some information about it, like you could see the sepal length, the sepal width in centimeters, petal length in centimeters, and as well as the petal width in centimeters. You could also see like the different classes it belongs to. So Iris setosa, Iris versicolor, and Iris virginica. And so Iris setosa is basically all these zero values over here. The second class over here, Iris versicolor, are all these ones over here. And Iris virginica are basically all these twos over here. So these are like different classes. These are different classes that belongs. Yeah, these are like our different classes. And you could as well like go through the documentation to read more about it. But I could keep that for you all. So now let's start by, let's say, visualizing. Let's say we want to draw like the dimensions of these flowers on like on a graph or something. So you could use like our scatter plot X. So since like our first 50, the first column. So in our case, this is actually the sepal length. We use the sepal length and the sepal width and plot that. So sepal length 0 to 50. Okay. Oh yeah, actually one over here. So these are basically this is a plot of like our sepal width and sepal length. You could also make another plot, the same thing, but now 50 to 100. Same thing over here, 50 to 100. Of course, you could also assign it like a color. Let's say R, red. And also the last class, let's say 100 to 150. And we could also put a different color over here, let's say green. Yeah. And for example, let's say if you look at this 2D plot, you could see that, okay, over here, if we want to like separate these classes, so our blue class, our red class, and as well as our green class, pretty much like a line could fit like a straight line over here that could like separate this blue class from the rest of our classes over here. And I mean, of course, like with an exception of this one point over here. And we could see that this red class over here and this green class over here, they are like intermixed in between each other. And so if we want to like design like a machine learning model, which we're going to see in the later classes on how to like separate these different classes, we're going to have to like, there's going to be like a bit of some misclassifications here. So basically over here, a straight line, we could fit like one over here that could separate this green class from this other classes over here, and another line that could separate this red class over here from these two different lines. Okay, so now let's start with like some visualization of like a simple chart. So let's do something like linspace. So want to create like evenly distributed of numbers within like a specific interval. So between from 0 to 10, I want to create like 10 different numbers. And we could do plt dot plot. Okay, let's see these numbers also to get an idea of what we're doing. So you can see these are just like, we're creating a range of numbers from 0 all the way to 10. And I'm telling you that, okay, between 0 and 10, split these numbers like into 10 different sections. So like 0, 1, 2, 0.2, 3.3, 4.4, all the way over there. And we could do like a plot with this PLT, the x-axis and the y-axis. So it's like a straight line. And okay. So now let's do something also with our iris data set. With like plot test equals x of, in our case, it should be, okay, I'm gonna have to use the sepal length, so it's the first column. So all rows, first column, and could plot it. Basically, this is like making a linear plot. So it's also like a straight line. And let's say now let's say we want to make like subplots. And if you're not quite sure what a subplot is, I could just show you quickly. So it's something like, for example, we want to make like a group of plots together. So let's say we have like one plot over here that could, let's say like a sine function, another one again, something like a cosine function. And that's like our goal, like to make like two plots, to join two plots into one. So you could do something like, you could make a range of numbers. So within like 0 and 10. And this is like the step size. So increase it by 0.2. Could print that out to see how it looks like. Here you got 0, 0.2, 0.4. So it's basically increasing it by 0.2. And we could say y is equals to like np sine of x. We could print that out. And the same thing, could do the same thing with z, cosine of x. And now we can put this two plots into one. So this can be done something like this figure. And we have like axis. I could do plt dot subplot. So plots, make different plots. And we could specify the rows. So if you saw from our previous diagram, we had like, okay, I could just open it again. So in our case, we had like the rows where we had two rows. So 1, 2, and one column. So we can specify that. 2 rows, and the number of columns be like 1. And we could also, yeah, okay, we'll do that later. So axis of 0. So basically in our first row, plot x and y. And we could visualize it to see how it looks like. So you see what it said over here. We could also give it like a label. Axis of 0 dot set y label, the sign over here. Now we could also do the same thing for cosine. So axis of 0, the plot x and z, axis of 0, and we set the label also the same way we did for the sine function, cosine. Oh yeah, and over here, this is because I specified, okay, for the first row, but now I want for the second row over here. So now I have our cosine plot over there. And if we want to like increase the size of this figure over here, there's also like an additional function parameter we could pass in. So it's called fixed size. And we need to specify the width, the height of the width, and the units are in inches, yeah? And as well as the height. So you can see the width, 10, and the height, 5. So, and now let's say that, okay, we want to like beautify our plot. So if you look at the background, it's just like a plain white, and they're like different plotting styles. And it's, you could see it in the library called plt.style and available styles. So available be, should get them here. Okay, so these are different like styles, and we could check them out to see how they look like. by saying something like, let's say plt dot style dot use. Let's say we want to use this seaborn dark style over here. Yeah, I could put it over here. So plt dot style, and you see the difference. So basically, we're telling, okay, matplotlib, use the style for our plot. You can see like the background's different. You could try out different ones. So you could try out the classic style. And that shouldn't take a lot of time. Yeah, there you go. And you could experiment with like different styles. So any questions so far? Okay.
I've got no questions from here.
Yeah. What's your question?
No, I said I don't have a question.
Okay. All right. My bad.
Thank
So we could also make something like a 3D plot. So that's also one good visualization to check out. NPL. So from this library, NPL to kids, import m plot 3D, and from matplotlib import cm. That's for like our color map, and we're gonna use that like later. And to create a figure, so plt.figure, we could set our fixed size. So we've seen how the fixed size work. We specify the width and the height, and create an axis. So plt.axis. We could set the projection equals to 3D, and we could make a scatter plot. So basically that erase flower, we're gonna see it in 3D format. So use like all the rows. We would take the features, let's say the sepal width and sepal length, x of 1. And we could do like a, yeah, let's see how it looks like. Okay, now we could specify the classes. So we could see like which groups they belong to by saying the color should equals my target variables. And over here, this y over here, okay, not this one. I need to rerun it again. Take this part of my code and this part. Okay, just put it right over here. So we need it. The different categories. So 0, 1, and 2. And once we put that as our color, so if you look carefully, okay, we could make it a bit much prettier by adding some color maps. Yeah, cmap equals to cm.ject. Okay, I think that's how best we could do it. We could also change like the viewpoint, the way from the angle that we're seeing it. So we could specify like elevate 20. So you can see different classes over here. So if you remember what I said, that in this plot over here, a line, within a line, we could use it to separate these blue classes from this other classes over here. But if we go into like a different dimension, a 3D, now we can't fit a line, but now we have to fit like a plane over there. So to like slice and cut like over here to separate this blue class from this green and also the red class. So fit in the plane over there. Okay, now we could also make like, now let's make a histogram plot. That will be useful. And p.random. Random.n, we want to generate data with the normal distribution. So let's say 500. And are you guys familiar with the normal distribution?
Yeah, I am.
Okay, all right. And we could make a scatter plot of this. So it goes within the range, length of x. So basically, this is just going with bringing out, giving us values from 0 to 499 and x. You could see like a scatter plot of this over there. And we could also do something. So let's say if we want to start from, so in our x-axis, we have like values all the way from negative 100 to 600, and we want to limit our x-axis. So let it go from like 0 to 500. We could use a function plt.xlim. So go start from 0 all the way to length of x, which is 500. Yeah, and there we could see. So now we start from 0 all the way to 500. You could also do the same thing for your y-axis if you want to limit it. So instead of xlim, you just use like plt.ylim. So you could go from, let's say, if you want to, okay, we're going to disregard some points. So from negative 3 all the way to positive 3. And you can see it over there. So now I'm just going to comment that out. And now let's make like a histogram plot. So you can use plt.his of x. And you could see over here. So this is, and yeah, we've got our plots over here. So values over here are much common or more likely to happen. And values over here, they're definitely like less likely to happen. So the different ways, if you want to get insight from your data, a histogram plot is also one way. So let's take for an example. Let's say we went out to like take like a group of people, a certain group of people's height. So we got like short people over here, average people over here, and tall people over here. And over here, which is like our frequency. So we have like less likely. And over here, all the way top over here, we have like more likely. And could fit like a Gaussian bell over there, something like this. So basically, it's rare that, okay, let's say it's rare that we're less likely we're gonna have like, if we go out and take like measurements of people, that we're gonna have short people. It's also less likely that if we go out take some measurement, we're gonna have like tall people. Well, it's more likely that if we go out and take some measurements, we're gonna have people of average height over here. So we could also make something like a box plot. So plt dot box plot of x. And you can see like what this box plot shows us is like, for example, we could see like the first quartile, and you could see the median value, which is this like this red or orange, I think it's like an orange line over here, the median value. And you could also see, so this is the median value over here, this is the maximum value over here, and this is the minimum value. And over here is like the third quantile, which is like 75%. And over here is like 25, the first quantile is like 25%. And we've got like this line over here. And these like symbols over here, like plus is over here. The what we call, they're called outliers within our data. So if we want to search, check, if our data contains like outliers. So if, yeah, you could also use this box plot. And it's also used, for example, if you're doing like feature engineering. So let's say that you okay, let's say we have like samples. Let's say we have like 10. We took like a group of people's age. Let's say we have a group of people's age. So 10, 12, 13, 14, and we have like, let's say 50, 100, the same thing, like 15 over here. So and let's say we have, let's say another value, let's say 10,000 over here. So in this case, if you sometimes you might want to take the average, but if you that's why it's good to see your plot and to see if you have outliers. So in this case, it's if you want to get it's not ideal to take like the, let's say, yeah, okay, let's say a good example. We have like different locations. So within, okay, I could give a new example. Let's say in different cities, let's say over there, I want to measure the amount of rainfall. So I get something like in this part, I got like 15 millimeters, and got like 16, and got like 17 over here. And over here, we got like 500. And you want to get like the average. So it might not really make sense to take like the average of this value. So 15 plus 6 plus 17 plus 500, because you're going to get a value between like, yeah, you're going to get a value very high. But in this case, you want to take the median value over here. So, and to get like a very good result. Okay. Any questions? All right. Okay. The next, so we could make something like a bar plot. So what are show like, for example, relationships between numerical and categorical variables. So we could do something like import pandas. Okay, I already have that imported. So we could create like a data frame, pd dot data frame, and be random dot random. So now we use the random. So basically this is normal distribution. Sorry, from a uniform distribution, actually, yeah. So we have 10 rows and 4 columns. You could see how this looks like over there. And we could specify like the columns. So we've got like A, B, C, and D over there. Let's see how this looks like. Okay. Now to make this plot, a bar plot, we could use something like df dot plot. And what kind of plot do we want to make? We want to make a bar plot. Yeah, let's see that. So yeah, you can see it over here. So basically for this first row over here, we have like 0.7 over here. That's like this for this one. Oh no, actually, so in this case, we're gonna have something different. Yeah, we're definitely gonna have something different. So we should use this value, not this one. So we're here for this for our 0 was our this row over here, 0. So we have 0.7 that belongs to the category A. We've got 0.3 over here, 322 that belongs to category B. We've got 0.24 belongs to category C, and same thing for 0.39 and belongs to category D. And the same thing we do the same thing for each of these rows over here. Okay, and so let's make like a another nice scatter plot also again. So data frame 2. pd.dataframe p.random. Same thing from our uniform distribution. We're sampling from our uniform distribution. We could specify the columns. So we look like A, B, and C over here. And we could make the plot for this. Now we could make like a scatter plot. So X requires X, Y, and this amount of columns. So we got this correct. Oh yeah, X. So in our case, we're going to use our column A and Y. We're going to need for our X-axis, we use our column A, and for Y-axis, we use our column B. We plot it to see how it looks like. And let's say we want to change like the size of it. So the size of this dot should depend on our column C. So you could do something like size, which should be like, let's say, df of 2c, and we could multiply it. I mean, yeah, if you see, it's not going to do anything, but if we multiply it, let's say by some constant 500, yeah, you see the size of this dot increases based on our column C. And let's say if you want to put like, let's say a marker or something, you know, something like a line, you know, to you could see something like this, df plt dot xh align, so some 0, ls, it's 0 and 0, so the horizontal line, axis line, dash dash, could do the same thing for axv for the vertical line, so 0 0 dash dash. You could see like this. Okay, what is missing here? Yeah, plt.show. Yeah, so that's like a mark over. You want to put something over there. You could also specify the color of the mark of these like line if you want to go into like more details, like so like say hexamal, decimal, let's say 5 5 5 5 5 5 1 2 3 4 5 6. You could do the same thing for this one. Over here. Okay, might not see the difference, but let's say PB. Okay, it doesn't really show that much of a difference over here. We probably if we use like a different style for the background color, we see a difference. We could also make something like a group plot, a group blocks plot. It's also another tool that's using like exploratory data analysis. So you could set like, for example, you could set the style, say to just remember a good style. We could use this one. And also, yeah, this is from a C1 library. We don't want from C1, one from matplotlib. So plt dot use style, I think that's what it's called. Just a moment. Yeah, plt. Could use that up there. It doesn't matter. And df dot plot kind of it. Say box plot doesn't work. Okay, so if this doesn't work, we use like from Seaborn library. So Seaborn library is also like a great tool if you want to like make like very nice plots. So I could import that Seaborn as SNS. So you could do something like SNS.set style. Same thing. Yeah. So you could use something white grid. Yeah. And SNS.boxplot. And takes in the data. DF in our case. So we should get something like this. So these are like different groups. So we've got the A, B, and the C and the D. And these correspond to basically over here to what we've created over here. So basically this like a summary of our A column, our B column, C column, and also a D column. We could also make something like a pie plot. So we could specify, let's say let's say PLT, let's see, text labels. So we could say like C++, say something like Python, Java, and got like JavaScript. Got something like fractions, got 45, 30, 15, and 10. Let's say we could make the pie plot. So give it fractions. Yeah, so we could see it over here. So C++ is this bigger part, and Python is like this green over here. Java, it's this red, and JavaScript is this blue. But this doesn't give us much information, so we need to add more. Just based on looking at this plot, you will have no idea what's going on. So we need to add a bit of more, like add a bit more description to it. So let's say explode should be our fractions. So okay. Oh yeah, tlt.show. Okay, it doesn't show anything, but probably show much. We could put our labels. We need to specify our labels, yeah, and txt.labels. Okay, something. Actually, not this over here. It should not go here. So you could specify something like offsets. So these are like distance between the beginning and the end of like our object. So that's why it wasn't working. 0.05, 0 and 0. And this should work now. Yeah, there we go. So we got like labels over here, our plots. And I could do something like add more descriptions. So auto PC. So put like the percentage on our plot, 1.1f percent. Incomplete format. What exactly is missing? Auto percent. What's the error? Okay. So let's put something like, oh yeah, there we go. That's why. So now we give a bit more description to it. So you can see 45%, 10, 15, 30. So let's also add more details into it. So we put like shadow. You could set shadow to true. You know, you could do something like color equals SNS dot color palette. Use something called muted. Yeah, and this looks very nice. Plot over here. You can see 45% C plus 45% of people, let's say, know C plus plus, 30% knows Python, and 15% knows Java, and 10% knows JavaScript. And this offset over here that I specified 0.05 is basically referring to this our Python over here. So if I put it to 0, pretty much it's close. But if you want something to stand out, you can put it like that, 0.07. Do something like this over here. So any questions now? Okay. Now let's do something like let's work with a bit of some real data set so we could see like all these stuff and interpret it in a very nice way. So we work with a Titanic data set. So we could import it. So import pandas. Okay, we have that already imported. So we could read a CSV file. So I have one right on my GitHub repository. So I could just get it. And if you remember how we're able to read data sets from online. So in my case, repository, data set, and Titanic data set. Use the raw, copy the link, read CSV, paste the link over there. Okay, make it look a bit much cleaner. URL, pass in the URL over there, and header should be 0. So use the first row as our header, and you could see how it looks like. Just a glimpse of it. So we've got like, if you're not familiar with this, the Titanic, it's pretty much if you watch the Titanic movie. So basically the biggest shipwreck that happened. So we could see like the passengers' IDs, people that survived. So basically each patient, it's like not patient, but the name of the person that boarded. If the person survived or didn't survive. So we got like Browd and Mr. So he's a male, of course he didn't survive. We got a female and she survived. The sex, the gender. We've got like the age, siblings and spouse, parents and child, the ticket, the fare, the amount they paid, the cabin they belong to, and where they embarked on the journey. So now we could do something by checking, okay, the data dot size. So basically these are all like the total number of elements in our data frame. So it's like the rows times the column. I got like 10,699. Okay. You could also check some like information about it. Data.info. So you could see something like the passenger ID survived and all the rest over there. So over here you see null count. So really there are no non-values over here. But over here for the age, they're like missing values. And as well for the cabin, they're missing values. Here we could check like data dot is null, sum. Gives us, yeah, we could see, we could sum them. Yeah, so we could see over there that we have around 687 non-values within the carbon and 117 non-values in our age. So let's say we want to visualize, like, let's say we want to count like the survived and the people one in our column, survived column, want to count the total number of people that survived and the total number of people that didn't survive. So you could do data dot survive column, survived. So this we get that specific column and could do something called value count. And there, so we could see like 549 people didn't survive. It belongs to zero. And 342 people actually survived. And we could also do the same thing for like, for example, want to see, okay, what, want to see like the class they belong to. So P class over there. Could also do some for the P class. You could see how it looks like. So these are different classes. You could check, you could use a unique function and unique, number of unique data dot unique. Oh, since it's not a data frame, okay, it's not there. Yeah, but I saw it. Now for this column, say P class. So there's three unique values over there. So now let's make, let's say, so since we've seen how to like make a pie chart from scratch and also, let's say, and also a bar plot, let's do the same thing for like this data set that we've done. So if you remember how we created like subplots, so we could, so basically now what we want to do is that we want to create a subplot, so something like this. So we have like a pie chart that I could say, okay, this amount of people, let's say, not the exact numbers, but a rough estimate, 80% of people didn't survive, and let's say 20% of people survived. But this is going to be based on our data, information that we got from our data. And beside it, we're going to make like a box plot, bar plot, actually, to see, for example, something like this. So we've got like a very high number of people that didn't survive, and we've got like a low number of people that actually survived. So that's like the goal. That's what we want to do now. So we could create this axis. So plt dot subplots. So now in my case, if you saw in this diagram, in the previous one we did with the sine and cosine, we had something like this. So basically we had two rows and one column. But now in my case, now what I want to have one row and two columns. So basically one for the box plot and one for the bar plot over here. So now number of rows, one, and number of columns, be two, just to get an idea of how it looks like. Yeah, something like this. You could also put like specify the size of the figure, 18 and 8, so the width and the height. And now we could do something like a data dots, so survive dot value count. So basically this is like value count, we've seen this. And make a plot. What type of plot? A pie plot. Let's see how this would look like. No, not this. T over there. Okay, but now it's like over there, so it doesn't know where to do it to make the plot. So we need to tell it, okay, like in our first row, first column, set, let's set the type to something like, oh yeah, actually over here we need to specify it. Yeah, ax of 0, make the plot over there. So basically we're telling that, okay, this x-axis, if you read the documentation, so let's just read the documentation a bit. And it's very good to read the documentation so you know exactly what you want to get. Okay, PLT. Oh, yeah, pi. Yeah, over here. So just increase it a bit. So we have like I guess there are no axes over here. axis, and another axis over here. But the idea is like we're telling that okay, this axis. So basically, this plot, put it over here in our first row and first column. So that's like the idea. That's what we're telling it to do. And we could also add, okay, do something like, let's say, do the same thing for our bar plot. So we could use something called count plot. And what this does is that it counts the, so you could have, what it does is that, so you want to count the number of categories. So a count plot can be thought as a histogram across like a categorical. So instead of quantity variable. So the idea is that we want to do something like a column plot. So basically like something like a histogram across categoricals. So do something like count plot survived, and the data should be from, get it from data and put it over there, axis of 1. So in our first row and second column over there. So you could see something like this. So this 0 over here represents the number of people that didn't survive, and 1 over here represents the number of people that actually survived. So basically, we're doing a count plot over on a histogram. Yeah. And you could also set the title of this one. So we could do something like set title, survive, and AX. Yeah. And we could also do the same thing for our pie chart. So that AX of 0. Let's set title, survive, and something like this. And also you see we've got like this label over here, so we could remove it. X of 0 dot set y label. So something like this, empty. And we also have it for the count, so we could also remove it. And now 1. And we've got like our plot over here. And if you want to do the same thing by like putting this one out with outwards a bit so it stands out, you use something like the, if you remember the explode function, explode parameter, explode. So 0 and 0 0.5. Oh, that's way too much. Say 1. And something like this. And you could also add some shadow into it. You could also add the number of percentage. So do something like this. We got auto PCT 1.1 F and 2 of those. Yeah, something like this. Okay, so now let's do something like so in the feature types, we have like different types of features, and those features could either be like categorical features in our data set. So some examples of categorical features are basically our sex column over here, so male and female. We could also have like the embarked, so SC, and also there's one more Q over there. And we could also have something like ordinal features, and ordinal features in our case are, for example, this P class over here. So you might wonder, okay, what's the difference between like categorical and ordinal features? So categorical features, of course, there is no clear ordering. So could have either male or female over there. But ordinal features, there is a clear ordering in it. So you have like one, two, three. So this B class over there. And we could also have something called like another one called a continuous features. So that could be like age because it like increases. So now let's say we want to like analyze the number of survivals by sex. So we could do something like data. So since by sex, so data of sex and of survived. And we could use the group by function. I guess you're familiar with this. Sex. And it should give us, okay, the get like the mean and plot it. So a bar plot over there. Okay, you might wonder, okay, this is like a lot of functions, can you like break it down? Of course, okay. So a much simpler approach to this is like, let's say data of, so we're interested in our sex column and survived. So what these two different features. Now we could do something like, okay, say B is now, okay, now group this or what we have over here, group it by or sex. And of course, with the group by function, you need to use aggregate also functions. So this is like the mean, the average, the sum, max, and min. So over here, so we've got the mean value over there. And if you want to make this plot, so you could do something b dot plot, and that's plot you want, a bar plot. So it's basically the exact same thing over there, but a much simpler step. Okay, so we could also do the same thing for like different classes. So let's say we have like for our P class, our passengers class, whether they belong to like class 1, class 2, or class 3. So values count. So we've got that also. We could make like a plot, so a bar plot. Here we go. But now we want to like change the colors of this, of course. So use, we specify the color. So we could have something like, let's say, CD F4, F7474. We could have something again like, let's say, 55442288. We'll have something like this, 232323. So these are like, this one corresponds to this one corresponds to this one, and the last one corresponds to the last one over there. And what else could we also do? We could also do the same thing. So we could do like a count plot also for like our embarked. And yeah. And could interpret impact. So, oh yeah, data, specify the data. Yeah. We've got like different, so more people embarked. And if you check in more detail, this is like a part of a town in a specific location. And if you want to say, let's say you want to view like the survivals depending on like the city where they embarked from, so you could specify hue should be like survived. So over here, the people that embarked and got into the ship from this town. Okay, a lot of them didn't survive. And over here we got one. So the number of people that survived are like around 200 something to, let's say, 215 or something, from also this town over here, and also from this town over here. And so, are there any questions? All right. And just to like confirm, okay, so this count plot, what it does is like it shows like the count of observations in each category and each categorical bins, yeah, using bars. So in each bin using the bars, so for this S and C and also for the Q. So now, they any questions if I end the tutorial? All right then. Thank you very much for listening.
Thanks, David Praise.
Thank you.
Awesome. Cheers, everyone.
Bye.